Okay, here we have section 7.2, similar polygons. So main idea is identify similar figures and then solve problems involving scale factors. So when polygons have the same shape but different size, that's referred to as similar polygons. So here's what makes this polygon similar. Two polygons are similar if and only if the corresponding angles are congruent and the sides are proportional. So if you look, so B is congruent to B, A to A, D to D, C to C. And if you look at the value of the sides, these values are all half those values. Now that has to be the same. Like you can't divide 7 by 2, you get that, and divide 6 by 6 and have a 1 there. That division step has to be the same no matter which side you're going to. So just things about similar polygons, so congruent angles, corresponding sides, the ratios all have to be the same. So example 1, determine whether each pair of triangles is similar. Justify your answer. There's a little bit of typo here. That is 6 times the square root of 3. That is 4.5 times the square root of 3. Now you have to be careful because these triangles are rotated from each other. Corner F and corner C are the same thing, E and B are the same thing, and D and A are the same thing. So when I pair off my sides, on the big triangle, 12 would pair off with 9. So I have to check that ratio. 6 root 3 would pair off with 4.5 root 3. And then lastly, 6, I'm just going off the bottom of the page, that would pair off with 4.5. I need to check what those things are equal to. So 12 divided by 9 is 1.3 repeating. This one would be, let me check, 1.3 repeating. And this one is also 1.3 repeating. So yes, they are similar because the angles are congruent, a 90 and a 90, a 30 and a 30, which means that B and E are both 60 because that's a triangle, has to add to 180. And the ratios of the sides are all the same. All right, example 2 here, you have a pair of rectangles to justify your answers. So on each rectangle you have a long side and a short side, so you need to just check the ratios for longs and shorts. So for the longs, it would be 7 over 6. For the shorts, it's 6 over 5. So 7 divided by 6 is 1.16 repeating. 6 divided by 5 is 1.2. So these two things are not equal. So that is no, they are not similar. When you compare the lengths of corresponding sides of similar figures, you get a ratio. So like this, these are the ratios. On the previous one, it was the 1.3 repeating. That's referred to as the scale factor. That tells you what you have to multiply by to go from one figure to the next. So example 3 here, the length of a car model is 6.5 inches. If the length of the actual car is 13 feet, what is the scale factor of the model compared to the car? So the model is going to go on top. The car is going to go on the bottom, but you can't do this because your units are not the same. So I'm going to turn 13 feet into some number in inches. So to do that, you have to multiply by 12. So this is 156 inches. And then inches cancel, and I just need to reduce 6.5 over 156 is 1 over 24 is the scale factor. So the model is 1/24 of the actual car. Example 4 here, so it tells you that they are similar. Write a similarity statement, then find x, y, and ut. So similarity statement would look like this. R, S, T, U, V is similar to A, B, C, D, E. Now you have to go in order. So if you start at the single arc, you start at the single arc. So I went single, double, triple, quadruple, pentuple. Same order going that way. So to find x, I can set up some ratios. So where's the x? There's x. So we're going to use a proportion. So I need to pick a pair of sides I know both of on each shape. So in this case, it's ST and BC. So 18 over 4. So to find x, I'm going to put x because it's on top, and I put the big shape on top. And its partner on the small one is 3. Then do cross products. 4x is equal to 3 times 18, which is 54. So x is whatever 54 divided by 4 is, or 13.5. So you can do the same steps to find y. It's down here on the bottom. So I'm going to use the 18 over 4 again because it's the common sides. And then y plus 2 over 5. So for cross products, that's 4y plus 8. That 4 distributes is equal to 90. So 4y is equal to 82. 82 divided by 4 is 20 and a half. And then lastly, to find UT, UT is here, y plus 2, so it's 22.5. Just plug that in. And then find the scale factor. So we actually already know what it is. It's 18 over 4, which is 9/2. It's that common fraction that you use. That's always the scale factor. All right, last example here. ABC is similar to XYZ with a scale factor of 2/3. If the sides of ABC are 6, 8, and 10, what are the lengths of the sides? So I actually set up 3 proportions, 1 for each side. So 2/3 is equal to 6 over X, 2/3 is equal to 8 over Y, and 2/3 is equal to 10 over Z. And then just solve those. So this is 18 is equal to 2X, so X is 9. This one is 24 is equal to 2Y, so Y is 12. And this one is 30 is equal to 2Z, so Z is 15. So those are the lengths of the sides, 9, 12, 15. That's the end of this section.